Math 113, 5-7, inverse trig functions. All right, so inverse trig functions, let's start with the inverse sine function. So I'm going to write it just in words so that you can see exactly what I mean. All right, the inverse sine function, this is the notation for it. Now, we can only take the inverse sine function only of a restricted, be great if I could spell, wouldn't it? Only if it is a restricted sign. And so here's what I mean by restricted. So we've got this equation, y equals the sine of x, but we are going to make sure that our x value stays between negative pi over 2 and pi over 2. We're only going to look at this restricted area of the sine function. Sine does go on forever. Okay, so let me just clarify. We know that sine goes on and on and on and on. Okay. To decide if it is actually has an inverse, it has to pass the horizontal line test. Well, I don't know if you remember what that is, but the horizontal line test says if a horizontal line touches it in more than one place, it is not does not have an inverse. So that's not what we want to happen. So what we're doing by saying this, by saying let's restrict it to negative pi over 2 to pi over 2, because that would mean we're only looking at a portion of the graph. Okay, we're only looking at a portion of the graph from negative pi over 2 to pi over 2, and now a horizontal line only touches it once. Okay, that part you don't have to be able to draw and all that good stuff. It is important to know we're restricting this between negative pi over 2 and pi over 2. So, why the inverse sine of x? Here's what that actually means. We are looking for the sine of some angle y that is the value of x. See what happened there? My x and y, see what happened there? The inverse sine of x means we're looking for the sine of some angle y that is equal to x. Okay. So let's try that. Now, these are going to be exact values, and anytime the directions tell us exact values, our calculator really doesn't do much good. So when we're looking for, when our directions say find exact values of the inverse sine of x, the first thing that we're going to do is we're going to say, okay, I'm going to let theta equal the inverse sine of x. All right, some angle whose sine is x. Okay, that's what we're looking for. Some angle whose sine is x. All right. So once I say that, then I can rewrite it to say I'm looking for some angle whose sine is x. And then the next thing we're going to do is we're going to use the table, or you could use that unit circle. I love that unit circle that I gave you in Moodle. It's got everything listed on there. I am going to draw you a table for the sake of us being able to talk about this right here on the board. All right, so here's the table that I'm going to be referring to at the moment. Oh, I'm so sorry. All right, so in our table, I'm going to give you theta values and I'm going to give you sine of theta values. We're going to start with, now remember I restricted this to negative pi over 2 to pi over 2. So we're going to start with negative pi over 2. But then we're going to include all those other important values on the unit circle. Okay, so that's where these values are coming from. On the unit circle, all of these are marked for us. Just for an easy way of you thinking about it, they're all 30, 45, 60, 90. And 0. Okay, so I'm doing that in radians. So if I'm looking at my unit circle, the sine of negative pi over 2, remember that would be the y value at negative pi over 2 is negative 1. At pi over 3, it is negative square root of 3 over 2. So these all come from that unit circle. Okay, I'm just going to put them in a table so that we can quickly refer to them as we learn a new concept here. Okay, so we're going to use this table to help answer the next questions. All right, so we're going to find the exact value. Let's start with the inverse sine of the square root of 2 over 2. Okay, so let's look at these steps up here above. Okay, so the first thing I said, let's let theta equal that thing. Okay, so if I use that little step, then I'm going to say, okay, theta equals the inverse sine of the square root of 2 over 2. Which means the sine of theta is equal to the square root of 2 over 2. All right, so now we look up here at our table and find the square root of 2 over 2 for sine. That goes with what theta value? It goes with pi over 4. So the answer to number 1 is theta is pi over 4. Okay, let's try another one. Let's do the inverse sine of the square root of 3 over 2. Okay, so we start by saying theta is going to equal that thing, which means I can rewrite it to say the sine of theta is the square root of 2, square root of 3 over 2. So go to my table, find the square root of 3 over 2, and what theta goes with that? Theta is pi over 3. Okay, using our little table there. Now, I say using the table loosely. We are going to be most of all using the unit circle. The only reason I said table is I wanted to throw it right here in our notes for us to look at. But having the unit circle gives us the same result. Okay? So we can do not just inverse sine, we can also do inverse cosine. All right, and our inverse cosine function is only restricted to these values between 0 and pi. So y equals the cosine of x, with x being between 0 and pi this time. So inverse cosine, again, that notation looks like this, which means the cosine of some angle y is equal to x. All right, so let me give you that little table again. Okay, our table is different because we're going to get cosine values and our theta values are changing. This time they're going from 0 to pi. And again, we're still using all of those values on the unit circle: 30 degrees, 45 degrees, 60 degrees, 90 degrees. Keep going around our circle until we get to pi. Which would be 180 degrees. Okay, so if we look at our unit circle, the cosine at 0 is 1. The cosine at pi over 6 is the square root of 3 over 2. Square root of 2 over 2. 1/2. 0. Negative 1/2. Negative square root of 2 over 2. Negative square root of 3 over 2. And negative 1. Okay, So now we've got our little table, and we're going to solve these just like we did the two sine functions above. We're going to let theta equal our inverse function, and then we will find theta. All right, let's do the inverse cosine of the negative square root of 3 over 2. Okay, so if we do what we were doing above, let's say theta is equal to that inverse cosine. Okay. So now let's say the cosine of theta is the square root of 3 over 2 negative. So now we go to our table. All right, go to our table and find negative square root of 3 over 2. It's right here. What theta goes with it? Oh, it's 5 pi over 6. So theta is 5 pi over 6. Theta is 5 pi over 6. I don't know why that looks so ugly. Okay? And we could do lots of other values, but the process is the same. Okay, tangent also has an inverse function. All right. And it is restricted to negative pi over 2 to pi over 2, but notice it is no longer equal to pi over 2 or negative pi over 2. It's just between them. And so we're looking for some angle whose tangent is x. All right, so I'll give you a table here for tangent. Again, this table is nothing magical. It is the unit circle, okay, just written out in table form. So I said we're not equaling negative pi over 2, so we're going to start with negative pi over 3. Negative pi over 4. Negative pi over 6. 0. Pi over 6, pi over 4, and pi over 3. Okay, so if I look at my unit circle, remember tangent is the y value over the x value of the ordered pair on the unit circle. So for tangent at negative pi over 3, I would end up with a negative square root of 3. At pi over 4, I would get negative 1. I would have to rationalize the pi over 6 and get negative square root of 3 over 3. At 0, I get 0. At pi over 6, positive square root of 3 over 3. Pi over 4, 1. And pi over 3, square root of 3. So if I said, let's find the inverse tangent at the square root of 3. And so we just use our table just like we've been using our table. Okay, so I need to find square root of 3 on my table. It's right here. I find the theta that goes with that, and I found that it was pi over 3. So theta is the inverse tangent. So the tangent of theta is the square root of 3. And we just found that theta is pi over 3. That is a 3. Oh boy, not sure where that went. That sure did go away quickly. Alright, so theta is pi over 3, just using our table. Now, every time that MyMathLab asks you to do an inverse tangent, it won't fall on the unit circle. And so if it doesn't fall on the unit circle, we are going to have to come up with some other way, okay? And so you've got to be real careful. If the directions tell you to use a calculator, then make sure you use it. If it says not to use a calculator, then make sure that your process does not use a calculator. So we're going to actually practice on your calculator for a moment. So make sure you have a calculator handy right now. And so we are going to use a calculator. To find theta to the nearest 4 decimal places. All right, so you're going to need your calculator here just to make sure that you understand what's going on. And so when we're doing this, when we are asked to find theta, okay, I really wish that they would be a little more specific in my math lab, but make sure you pay attention to the little directions in parentheses below your answer box. Sometimes it does tell you, hey, make sure your answer's in radians. But when we're asked to find theta, it is definitely going to be in radians unless they tell me otherwise. Okay, so let's use our calculator and find the inverse cosine of 1/3. So there is a button on your calculator that says inverse cosine. It's got that cosine with a little -1. So you may have to hit the shift button or the second button on your calculator. It depends on what kind of calculator that you are using. All right, so find that little button that says inverse cosine. Right, and then we're going to do that of 1/3. You should get 1.231, and we are asked to round to the nearest 4 places, so that's why I ended up with 10 at the end. All right, so one more to try with your calculator. If you are having calculator issues and you are not getting these answers using your calculator, just you and I can meet in a Teams meeting and I can show you, because that way I can see your calculator and we can talk about it. All right, so find your inverse tangent button on your calculator and let's do the inverse tangent of negative 35.85. Again, your calculator should be in radians. Okay, if your calculator is not in radians, you're not going to get these answers. Okay, and so this time we should get negative 1.5429. Okay, your calculator should be in radians. All right. If you have a question about that, if you are really struggling with your calculator, you and I can meet in a Teams meeting. That way I can see your calculator. So just let me know. Okay, let's get away from the calculator now. So there are some properties about inverses that are important to us. So these properties would be super helpful to have beside you while you work these problems when you get ready to do the homework. All right, this really does say find the sine of the inverse sine. And we do get x, but only if x is in the interval -1 to 1. And we're going to do some where it's not in the interval, so you'll know what happens if it's not. Okay, and then the inverse sine of the sine is also x. For x in, now this time the interval has to be -π/2 to π/2. So this is why this needs to be handy when you're working these, because those intervals are important. I'm going to show you when we do some problems. Okay, cosine of the inverse cosine is x. Okay, for x in the interval -1 to 1. The inverse cosine of the cosine of x is x. For x in the interval 0 to pi. Okay, we have to do tangent also. Tangent of the inverse tangent of x is x. Guess what? For all real number x values. So there's no limit there. And then the inverse tangent of the tangent would be x. For x in the interval, notice I have parentheses this time because it is not equal to pi over 2. Okay, so make sure you have this written down. You're going to need these intervals in just a moment to do some problems. Okay, so I'm about to move the screen up. Make sure you have this written down so you can have it beside you so that as I do a problem, you know where I'm getting my information. Okay, so there it goes. All right, so here's how we will do this. Find the exact value, which means we're not using our calculator again. All right, let's start with the cosine of the inverse cosine of 0.6. Okay, so I have to go back up to that interval. All right, so I'm going to pull it down. I'm not going to keep pulling it down. You should have this beside you. But I'll go back to this interval where it says cosine of the inverse cosine. Let me use a color so you can see it. Here we are. Okay, so this is the one I'm using here. So the x value in question must be between -1 and 1. All right, so let's just double check. Is 0.6 between -1 and 1? Yes. All right, so since 0.6 is in that interval, then my answer is just 0.6. Done. Okay, because it fell in that interval, so it works to say it's just 0.6. Okay, so let's see what happens when it is not in the interval. All right, so now we have to look at the inverse sine of the sine. Okay, so let's go back up here. The inverse sine of the sine. Okay, that's this one that I'm circling in red. All right, notice pi is not in that interval, -pi over 2 to pi over 2. It's not in there. Uh-oh. Okay, so this is an example of, so what do we do now? All right, so when it is not in the interval, find the value of the parentheses. Okay, so in this case, I'm finding the value of the sine of pi. So we literally go to the unit circle, go to the hand trick, go to that little table that I gave you at the very beginning of this lesson for sine at pi. So what is the sine of pi? Well, the sine of pi is 0. Awesome. Okay, so now we're going to go back up here to the original problem, and where it says sine of pi, we're going to put 0. So we're actually doing the inverse sine of 0. Okay, so we're looking for some angle whose sine is 0. What that means is theta equals the inverse sine of 0. So the sine of theta is 0. So go to the table and you find where is the sine of theta 0. Okay, I'm gonna attempt to scroll all the way back to the beginning there. Find that sine table so I can show you what I'm talking about. Okay, so here we are at our sine table. We're looking for where the sine is 0. I'm going to do this in purple. Okay, the sine is 0 right here. We're looking for theta that goes with it, which happens to be 0. All right, from using the table. All right, so let me scroll back up to our problem. Here we go. There we are. So theta is 0. All right, theta is 0. Okay, let's try another one. Okay, I'm not going to scroll back up. That just took too long. So make sure you have those tables close by. the cosine of the inverse tangent of 5 over 12. Okay, that is not any of those properties that was listed. Okay, so this doesn't even, those properties don't even work for this problem. Okay, so when the properties aren't going to help me, like I'm doing the cosine of some other function, okay, we've got the inverse tangent. All right, so here's what I'm going to do. I'm going to take what's in parentheses here, and we're going to come over to the side and go, you know what, that says theta is the inverse tangent of 5 over 12, which means the tangent of theta is 5 over 12. Now, we learned earlier in chapter 6 that tangent is the y value over the x value. Okay? Right? We're all good here? So x is 12 and y is 5. All right? So we learned that earlier on. So we are asked to find, now what we've just said is we're going to let theta equal the inverse tangent. So theta. So what we're really finding is, what is the cosine of theta? That's what we're finding. Well, yeah, awesome. Okay, remember we did problems very similar to this. It just starts differently than what we're used to. All right, so we've got our tangent of theta. Let me draw that. Okay, if x is 12 and y is 5, then I am about right here. And I'm not sure why I drew it in the fourth quadrant. That would be negative 5. Okay, x is 12. Let's say 12 is here and 5 is here. So here would be my theta. I could draw myself a little triangle. I know this is 12. I know this is 5. Remember that the value right there would be r. And now we have this little right triangle, and I could do the cosine if I knew what r was, because cosine is x over r. Okay, so let's just find the r value. Remember, we have a formula for r. R is the square root of x squared plus y squared. So r is the square root of 144 plus 25, which is the square root of 169, which is 13. Okay, so I've got, there's my x and y value, and there's my r value. So the cosine of the theta that we're asked to find is the x value we just found was 12. The r value we just found was 13. And that's the answer to that question, 12 over 13. Awesome. Okay, one more, and that is literally the last example, 4, 5, 7. Okay, let's do the cotangent of the inverse sine of negative 1/3. Awesome. Okay, now my little inverse properties don't work because I've got cotangent and sine in the same problem, so the inverse properties don't work. So I told you when the inverse properties don't work, let's take this stuff in parentheses, in this case brackets, and let's just do that first. Okay, let's just do that first. So theta is the inverse sine of negative 1/3, which means the sine of theta is negative 1/3. Now we learned that sine is y over r. We also learned that r can never be negative. So that means that the y value here is negative. So y is negative 1 and r is 3. Okay, y is negative 1 and r is 3. Okay, we can find x by using that same little formula again. So r is equal to the square root of x squared plus y squared. In this case, we have 3. It's the square root of, we don't know x. That's what we're looking for. If I square both sides, I get 9 is x squared plus, when you square negative 1, you get positive 1. So x squared is 8. Which means when you take the square root of both sides, we get 2 on the square root of 2 is our x value. 2 on the square root of 2 is our x value. Okay, so if I rewrote this problem, it really says, it really says we are taking the cotangent of, we renamed that theta. So the cotangent of theta, remember cotangent is the inverse of tangent. So cotangent is the x value over the y value. In this case, our x value is 2 on the square root of 2. Our y value is -1. So we get -2 on the square root of 2. And that would be our final answer. These are a little tricky, making sure you have the tables beside you or your unit circle, and then not forgetting the little things about sine is y over r, cosine is x over r, and tangent is y over x. And their reciprocals. They're going to keep throwing in cotangent, secant, and cosecant. Please let me know if you have any questions along the way.